Good afternoon and welcome to the Kentucky Center for Mathematics series of Zoom webinars. This one's called Let's Do Math. Today we have a special guest, Funda, and Funda is our faculty associate and has really worked hard for a presentation for you guys today. So Funda, I'm looking forward to it.
Okay, hello. I will share my screen first and then my presentation. Thank you for coming to this session. In this session, we're going to talk about how we can create opportunities in connecting fractions, decimals, and percents. This is me. I work for the Kentucky Center for Mathematics as a faculty associate, but I am also a faculty at Northern Kentucky University. And I already saw, I think, one of my students, Dakota. I want to just shout out. He was one of my favorites. So this is us. We provide a lot of professional development. And this is our website. I want to go ahead and start because we have just 30 minutes. Today's goals is more about thinking about numbers in relation to what this means to understand fractions, decimals, and percents, the same way as we understand whole numbers. We want to provide opportunities for students to develop fluency with these numbers. And the way to do is to use and connect mathematical representations. So I'll try to provide activities and some games ideas to support that understanding. For that purpose, I'll just talk a little bit about research, and we'll do a lot of review of activities, and we will unpack some key ideas, and I will end the session with some games. Okay. So the research background here is, I want to have this quote from the research team conducted by Kathleen Kramer. And I want to get this name out because she is one of the leading people who contribute to the research that we understand about how we can support students' understandings of fractions and decimals. And this little picture you see on the side is one of her teaching children mathematics articles talking about 5 indicators of decimal understanding. In this quote, the interviewer is talking with a 4th grader, and they are asking questions about these 2 decimal numbers, 0.38 and 4. The teacher, the interviewer, asked the kid, Violet, to read these numbers. Violet says 0.4, and interviewer asks, okay, how about this one? And asking the other one, 0.38. The interviewer asks, which one is larger, or are they equal? Violet will give an answer that you will expect to see in many of the students. Violet says 38. 38 is larger. Why is that? Because 38 is bigger than 4. I'm sure this scenario, this interview sounds very familiar to you because kids have this misunderstanding of just looking at the whole number parts that they see with the numbers. And the Kramer and her team talks about how this is about many of the indicators, missing indicators, like using precise mathematical language, using models, creating these mental images, and having an idea of this relative size of decimals and building meaning for work with the symbols. All these indicators made me consider this graph, this visual. This is how NCTM defines mathematical representations. We have multiple representations that we can provide to the kids to make sense of these numbers actually. We have visual, symbolic, verbal, contextual, and physical representations. And the mathematical learning opportunities happen when we allow kids make connections within these representations and within each representation also. Today, when I say decimals, fractions, and percents, I'm going to talk a lot about symbolic connections within these number names. But also, I'm going to talk about what are some visuals or some models that will help kids to make sense of these numbers. Okay, are you ready? All right, so these are my standards. As you can see, I am missing grade 6. I look very carefully to the standards in grade 6, and many of the ideas that I'm going to talk in here will speak to grade 6. but grade 6 standards, as they were written, were more focused on doing the algorithm, using the algorithm. So I will just go kind of provide this bridging perspective, connecting grade 5 work to grade 7 work. Okay, now I want you to think about this math question. Many people use benchmark numbers for determining tips. And Jill explains her strategy. She says that I figure out 10% and then I use this information to calculate 15% and 20%. Now we're gonna have, think about how we can use 10% to figure out 15% and 20%. Now I want you to find 10% and 5% of $20. And how are the 2% related? Please feel free to type into the chat box your answers, but I'm gonna move quickly in this one. And I'm gonna try to follow the chat box as well. Okay, so I'm just giving enough time to find 10% and 5%. I see 10%, $2. 5%, $1. Kelly says that as a former waitress, this is a skill I use weekly. So move the decimal ones for 10%, and half that for 5%. Darren says that halving, do you see the relation? Is the 10%, 5% is half of the 10%? I think you all noticed that. Let's use the same skill. And let's find 10% and 20% or $24.50. And again, let's try to imagine how the 2% are related. Now we are doing another quick math and we are trying to find 10% and 20% or 20.5, $24.50. Now to see a couple answers in the chat box so that I can see the relation. You know, the $24.50, a little bit harder than straightforward $20, right? So 10%, 2.4, and 20% is 2.45 times 2, approximately $5. Michelle says 10% is $2.45 and 20% is $4.90. Now think about this. Did you really actually calculate the 20% or did you use 10% information to figure out 20%? And I think Jamie and Cindy wrote that we just doubled, and Michelle says I doubled 10%. That's kind of the fluency we want the kids to develop, seeing this relation between these computations instead of looking them as isolated problems. Now finally, my final question is, first find 10% and $15 and use this information to find 15% and 20% of $15. And since we all think about this, I'm just gonna go through this problem together because I think, made a discovery that is required for this kind of thinking. How do we find 15%? This is my tape bar diagram. So see, I'm starting bringing my multiple representations. In addition to this symbolic work, the connection between 10% and 20%, we can make this visual. So if I imagine my percent on a tape bar diagram, starting from 0% to 100%, I can label the other part of my tape diagram as my dollars, starting from $0 to $20. So this is 2 units. This tape diagram involves 2 units. Now we have 10%, and can we figure out 20%? We can, right? Why I use this tape diagram? What is the power of using this tape diagram besides observing it with the number relations? Can someone talk about or type in the chat box what might be an advantage of tape diagram? And this is my 15%. What might be an advantage of seeing this visually by using a tape diagram? Rachel says that use the measurement to help visualize doubling and halving. see the part-to-whole connection, Michelle says, and Dakota says it will also create a form of number line. Students see the increasing amounts. Exactly, all these reasons. It provides this strong visual image. Remember, in the research background, Kramer was talking about these mental images that students need. That's indicator of understanding. This is one of the mental images. In addition to recognizing 20% is double 10%, we can see as unitized regions exactly this unit repeated over 2 times. So all you need to do is you carry the same unit with the measurement perspective, as Rachel was saying, bringing that measurement perspective. And 15%, you can see it's just halving 10%. So it's visual. And for some students, you can even make this tactile. Do you remember fraction strips, especially elementary teachers can remember fraction strips, where we make the kids fold the paper, the strips, and then fold the parts. You can make this even tape diagrams like fraction strips. They can fold them and then see the relations, so that when they are doing these computations, they become fluent. Instead of getting into the calculator or making long algorithms, they can just imagine, use one of the findings they use to figure out the other one. Okay, now another math question. Again, I have my tape bar diagrams, but this question is slightly different from the other question. What is different from this in this question? This is what is different from the previous representation I had. Look at this representation. Yes, Cindy is saying moving beyond 100%, more than one whole. And this is purposefully put in here because sometimes when we deal in percent situations, we just limit within the 100%. But the percent as the whole numbers doesn't have to stay within a whole. So we are trying to move, as Kelly said, more than a whole perspective. We are going to find out the missing number together by using the bit paper I created for our session. So I want a volunteer to describe how you can solve this problem. By using this representation. How do you figure out this question mark? Can someone tell us how to figure out a strategy to figure out this question mark?
Feel free to unmute and answer.
Yes, please.
Oh, way I would do it
Thank you.
is because well, it's not the way I thought it was. You know, you're halfway between 100 and 125.
Mm-hmm. So this is halfway between 100 and 125.
So that's like 12%. So, or you can go with 10, even a little bit more of the 200 to figure out where you're at.
So this is halfway between these two numbers. That's what we decided. So what can we can figure out this is about 112.5%, but that's not the question we are trying to answer. What is the amount that we need to have in here? So if this is the halfway, how we can use this visual to figure out that amount? And you can type in chat box. I'll just talk what you're typing in. I know we need a thinking time. I'll just give a little bit more thinking time. And then let's try to figure it out. So do you see these units? There is 0 to 200. And this is from 0% to 200%. So my first question is, what is 100% for this one? And then they already provided the benchmark number as well. So shall we figure out 100%? What's 100% in here? I'm just gonna put 100%. Jamie says that it is 100. It corresponds 1 to 1. Why it's 100? Because it's halfway through, right? So we are dividing this into half, and then this is halfway through. Okay, so we figured out 100%. How we can figure out the question mark? This is our 100%, corresponds to 100. Jacqueline says that, is it 112.5? Dakota says, I did 125 and 100 and then divided the sum by 2. Dakota, would you mind talking about why you divided the sum by 2? Can you explain your thinking? And I can call on you because you were my student.
So can you hear me?
Yes.
Okay, cool. So I did that because I saw it was directly halfway between 100 and 125. And I knew if I added up to the two sums and then divided by 2, I'd be finding the value of where the green bar ends, because that number has to fall directly between that range of numbers. So that was my thinking.
Do you see how he is getting? He even didn't think about 100%. That's why you shouldn't give leading methods to the students. So he saw that this is from here to here is kind of halfway. He sees it's the halfway. And then he added 125 and then 100 and then divided the sum by 2. And Cindy, can you talk about your method as well? That's slightly different from Dakota's.
I was more focused on the space, so from 100% to 125% is 25%. So half of that is the 12.5%, and then added that on to the 100%.
Okay, so you look at the space, and that the space is 12.5%. Did you do the percents or the numbers?
I focused in on the percents, but in this case, that wasn't easy. So that length from 100% to the end of the green bar is 12.5%.
12.5%.
And the location
because it's midway
is
through.
112.5%.
Yes. So we can care because this is midway through. Again,
And so
remember
the top
how
is 125.
Sorry. Yes.
Or I'm sorry, 112.5.
112.5. So this is 112.5. This represents the 12.5 I wrote in here represents only this side. The measurement of this part. And when we add these together, 112.5, like Jacqueline was saying, isn't that 112.5? So remember how we use the relation between 10% and 5%. We are actually using the same relation in a more visual setting. Okay, now look at this question. Let's move on. The code also said I focus on the percent and values. I know it was 1-to-1. Yes, the percent and the value is 1-to-1 correspond. So we don't need to worry about the different sizes of the units in this one. And Dee says that she focused on the empty space and subtracted 12.5 from 125. Different out of the box thinking, as always. Let's look at the second one. With the same idea, the second diagram. So what do you think this question mark corresponds to? Now we don't see the 100% is clearly. So what is this question mark? Feel free to take some thinking time and also type in the chat box. Kelly sees it's the same idea as previous, adding 12.5 to 125. Kelly, can you a little bit talk about why you see the same idea so that we see it the way you see it?
So I see the box has been moved along the continuum, and that top diagram has 125% and the bottom one has 125%. And that box that was between 100 and 125 was just moved up. So I'm assuming that that proportion matters. I tell you one thing that I'm distracted by is the fact that at the end number, it is a 400.
Yes.
So if you're asking me, so if the question changed, if it was 200, so I see 200 and 200, that now you doubled my value versus the percent, now going to double my answer, because I was initially telling you that it was a 137.5. And if my whole is now 400, so if I've doubled my value, then I'm going to double my answer to you. Instead of saying that it's 137.5, I'm going to double it to 278.
Do you see what Kelly is saying? The unit is different in this version. It was one-to-one corresponding in the previous one. Now it's 200% corresponds to 400. So even though we can find the percent amount, like we are just moving, iterating by halfway, 12.5, it will be, the amount will be doubled. So it's say 275. This will be 275. Michelle, can you explain your thinking a little bit? I see you type some beautiful thinking to your chat box, if you don't mind. Oh, I'm sorry. Michelle says that she has to type it, so I'm just going to read because her 6-year-old, and so I understand that completely. The relationship between 200% and 400 is 2 times, like Kelly is thinking. This is relation is 2 times. So what she's saying is you just double this amount to see the direct relationship between those 2 numbers. Okay, so we were able to use our spatial reasoning skills, that visual imagination, in order to figure out these percents. But what if I pose this question just, sorry, let me just move this one. What if I pose this question instead of using this tape diagrams? If I pose this question, I have calculate 137.5% of something. Isn't that a scary question? Just asking like symbolically by using finding 137.5% of something. Again, I'm going to refer back to what Kramer said originally. She said that the kids have strong mental images. Kids don't develop those strong mental images by themselves. These are the images we need to provide them so that they can see what a whole looks like, and then how going beyond whole, or using some benchmark numbers, will look like. I'm going to have also us to think to carry this visual into other visuals. Do you see I have a hundredths grid, and I also have a hundredths strip bar. These are my other 2 visuals, representations I want to introduce you today. I have these 100 grids, and as part of your handout, I didn't add this 100 strip, but you can easily create yourselves. So how will this representation look like on my hundredths chart, hundredths grids? Can someone talk us about how I can carry this first representation to this hundredths grids representation I have in here? We are going to carry this representation to this hundredths grids, 10 by 10 grid. How we can carry it? Will it represent the value or the percent? Let's go with the percent. That's a good question, Dakota. Let's represent the percent value. How I can represent the percent? This question mark, 112.5% on this 100 grid, 100 strip, 100 grid. Okay, I'm going to type it in here so that we know the question. We are going to represent 112.5 on the hundredths grid. James
I think
says that color the first grid completely and then color 12.5 squares on the second grid. Let's see. So I'm just going to do what Jamie said, and then if you have any other suggestions, let's make this bigger so that I can color easily. So we are coloring this whole thing, right? This whole thing. We need to color this whole thing. Why we are coloring this whole thing? Because we have more than one whole, right? Even though this is not the perfect coloring, I have some coloring. So this is my whole thing. And what happens in the second one? I'm going to go back to what Jamie said. Color 12.5 squares on the second grid. This is my 1 square. And then I think I need to make, this is my 10 squares. Let's make it a little bit small. And then this is my 12. And then I'll just go halfway here. Okay. This is not the ideal one. But you see, I have one whole, and then I have a 10, 11, 12.5 square. Why I make us to use this representation? What might be the advantage of using one diagram and then representing in another diagram? Think about that. And if you have an idea, just type in chat box. I'll read it. I see some other answers. Yes, students see things differently, but also there might be some advantages. One diagram, one representation may not bring. These tape diagrams are great because they are continuous. You don't need to cut out. But do you see one hole separately in this tape diagram? We don't, right? We don't see one hole separately. When I bring up my 100th grade separately, it will show the 100% this whole as a separate whole, and then 12.5 as an addition to this whole. So it will make their mental image stronger because they see that this 112.5% has one whole and 12.5 filling extra boxes. Yes, it is also, Dakota was also saying that it is filling up their toolboxes so that they can use whichever tool they want to use. Remember in our presentation, I'm going to go back to our presentation, the diagram that I showed you, the visual representations, this was calling for connections between the same visual also. Now, when I provide different visuals, like the grid bar, tape bar, 100 strip, and 100 grid paper, students will see how the same ideas might slightly look different, but still the same idea. So we are allowing kids to make this abstraction between different mathematical ideas, because it's still one whole. One whole looks differently in this one. If I use this 100 strip, I needed to color this whole thing, and then some additional 12, 10, and then 2.5. In this one, I colored this whole thing in one whole column and 2.5. So it will allow these multiple entry points to the kids. Okay, now another tool, another visual to introduce to the students. Remember, in this one, we use 100th grid, 100th strip, and tape bar. Now our beautiful number lines with an open middle problem. So this is kind of completing what Cindy started. Cindy yesterday talked about a lot of open middle problems. Now here is another open middle problem for us. This time our representation is a number line. The same idea, I have the units of percents underneath and the real units on the top. So type in chat box, take some time to think about this problem, and the direction is using the digits from 0 to 9, at most one each time. Can you fill in the boxes? And then if you have one solution, how many other solutions you can find? Time is flying, right? We have just a little bit time, so I might need to move faster. So I'm just gonna look at the chat box. If you have some answers. You're still thinking, this is a little bit challenging, right? For the consideration of time, what I'm gonna do is I'm just gonna give you a hint, okay? Are you ready for my hint? What if I chose 7 and 5 to fill in my 4% boxes? How would you fill in your box to the top? And also, as you are filling, try to think about what mathematical ideas kids are needing to answer this question. Okay, here's my hint. Does this help, the hint? All right, let's move on a little bit more. And here is my answer. One answer, one possible answers. About 9 to 12. Because the relation between 75 and 100% is 3 to 4, 3/4. So I can use 9 and 12, and Cindy came up with another answer, 39 and 52. So once we figure out the relation between the part and the whole, we try to create an equivalency relation. The relation between 75 and 100 is 3/4. So I try to keep the same relation. So that takes us to the proportional reasoning, setting up the equations. It's okay, Cindy. Okay. Now I'm going to introduce a couple games really quickly. It's like shopping some games that you can use, allowing kids to make these connections. The first game is from Math Shell website. If you haven't looked at this website, please go ahead and look at this website. This website is like rich with the tasks and activities appropriate for middle school and high school. There are some elementary ideas, but most middle school and high school. In this one, these are cards for percent and decimals, and students fill in the blanks and then put the cards in order. Once they put the cards in order, this is how we complete. We write the equivalencies. If we have decimal, we write the percent. And then this empty card is for missing cards. We will have some missing cards. They get other representations like fractions, area models, or scale representations. And one by one, they get these cards and they put them in order and match these cards. The gray cards are for the missing ones. Now it's time for them to fill up these missing spots, and then our ordering is complete now. This is a card sorting activity. Another one is they can do in the live number line. What they need is, all you need is some clothesline and some cards that you can prepare at home or at school. And then we hang the cards on the clothesline. I presented these 3 images because there's 3 different ways that you can facilitate this activity. One way is they can hang the related cards together, like by using this little attach, or they can use whiteboard to write equivalent cards. For example, if there's a fraction card, what's another equivalent fraction name, or what's an equivalent decimal name, or you can use separate clothesline to allow represent all 3 fractions, decimals, and percents together. Finally, the second version of live number line is students are given decimal number cards and they put themselves in order. I provided these decimal cards. You can create your own decimal cards, but the beauty of this activity is once they put themselves in order, they're going to claim allies. Who is close to 0? Who is close to 1/2? And who is close to 1? And for what purpose? So the discourse matters more than the actual outcome. Because here we want to have this idea of relative size of these decimal numbers. For example, knowing that 700 is closer to 0 than half is a big recognition for these kids. Okay, so the idea, I had the interactive, but I'm going to miss that. Which one is closer to the half? When they are claiming their allies, for example, is 0.391 is closer or 0.599? And then they can debate it, and then they can explain their reasoning when they are deciding which one is closer to this number. And then they can do card sorting. You can create different card sorts. These are a collection of cards that I created. Card sorting is finding the same quantities together. As you can see in my card sorting, I provided a variety of representations, decimals, fractions, visual, and even equations. Get creative and you can create as many different cards, allowing for card sorting. Finally, getting close game. This is my favorite game. This is from Connected Mathematics program. How they play this game, I know we are over the time, but I'm just going to describe this game because this is so good game, and then I'm going to end the presentation. What we have is we have a set of 4 square number cards, 0, 1, 2, and 3, and then fraction or decimal game cards. That you cut out those game cards. These are my game cards, fraction cards, and decimal cards. These cards, you you can choose to play with fraction game cards, or you can choose to play with decimal game cards. These are cut out and then placed face down. Kids can play in partners. They pull, the first player picks 2 fraction cards if you're playing with the fraction cards. For example, I picked 1/4 and 1 1/3, for example, 1/4 and 1 1/3. Players use their guessing cards, 0, 1, 2, and 3, to say which number is the most closest for these sums. So imagine I have 1/4 and 1 1/3. Which number will be more close when I add these 2 numbers? Just think about it. I have 1/4 and 1 1/3. Which game card would you use as your estimate when you add these cards together? 1/4 and 1 1/3. Would you play your 0 card, 1 card, 2 cards, and 3 cards in order to make an estimate? Mary says 1, Michelle says 2, Jamie says 2. See, this is why this game gets so heated, because people will have different ideas and they will argue about it. And to check their work, I usually let the kids use calculator, because this is about estimation. This is not about being exact. So I don't ask the kids to do the exact computations, but you can do that. Which one do you think? 1/4? Is it close to 1 or 2? That's a question for you to leave it. You can check with your calculators. But this is a fun game for them to play with. So I have all these cards. This is from CMP, and luckily CMP had these game cards on their website, so I was able to pull for your handout. And this is the last game I have for you. And I have some online interactive resources as well. I have a link in here to NCTM, which puts fractions, mixed numbers, decimals, and percents all in one screen in an interactive website. So you can allow kids to play with this as well. And this is our website. And these are our upcoming trainings. Thank you for your time, questions, or anything.
So we always like to end our KCM sessions by giving our presenter, who has worked diligently to put together that presentation. I had fun doing the math, still working on that open middle problem. So we're using a 7. So
I know that was a hard one, and I took my time, and I knew that was going to go quickly. But it was a good
fabulous. We always want to give Funda some feedback. So unmute your mic and let her know what you love today, or you can put it in the chat.
I just got an idea for things that we were thinking about when hopefully we get to go back into doing things in person. Is we do a lot of work with the quantity line. So thinking about it as a percent line pulls a tool that we've used a lot with intermediate solidly into middle school. So I'm excited about that.
Yeah, and I also like how, in our trainings we do a lot. So there's a lot of room that we can incorporate our training. So yeah, I think that's definitely a great idea.
I really like that the materials that you gave us for those card sorts, you know, guys, it doesn't require a printer. So I put that in the chat box, but I could just get little pieces of paper, have the kids put some stuff on it. That's easy to do at home. It's an equity thing. It's allows all kids to be able to access that. One of the things that we want to encourage you guys is to say that here from the Kentucky Center for Mathematics, we say that now is the time to slow down. The materials that we're giving our students, one good rich problem with some really good conversation on the backside. Let's take advantage of this time and really, really allow kids that opportunity to think about the mathematics, to talk about the mathematics. And so we encourage you to take the materials that we're giving you, but we're also encouraging you to slow down. This is the time for the rich tasks. imagine when you give Funda's tape diagram and then the kids see that it went from 200 to 400, that was kind of exciting when she did that. I thought, okay, now here we go. What are those relationships there? Nice conversations. Funda, your time and effort has been appreciated. Beautiful presentation. It was good. There are a good, what was our highest? 30-something participants, maybe in the mid-30s at this section. So we want to thank you, Funda. We're developing quite the community of learners, and tomorrow just as fabulous. So thank you. We appreciate you guys that are our KCM treasures, as we call you.